All right, so we're working on this question from bottom of page 7, top of page 8 in the digital workbook. Okay, and the first thing it's asking us to do is find the position at these various times. Since this is a position versus time graph, all we have to do is look at it. Okay, this is something we can read right off the graph. So what's the position at time 0 seconds? All right, here's time 0 seconds. All right, so my position is positive 30 meters. Go. Okay, 6 seconds. All right, so at time 6 seconds, this is where we are right here. Okay, so that looks to be negative 15 meters because it's right smack in the middle of those two lines. Okay, and each line is worth 2. So, okay, negative 15 meters at time 6 seconds. And then at 14 seconds, okay, so looks like positive 25 meters to me. All right, and I would say, like, I would give you, +1 or -1 on that, okay, just on reading error. Questions on that first one? Okay, how many people have done the second one? Okay, let's look at the second one too then. Didn't think that would take you guys very long. Okay, total displacement to time 2 seconds, time 4 seconds, time 11 seconds. So displacement is always calculated by going final position minus initial position from a position versus time graph. Okay, so our position, our initial position for all of these is positive 30 meters. Okay, so at time 2 seconds, which is right here, my position is 50 meters. So 50 minus 30, right? This one would be positive 20 meters. All right, and then at time 4 seconds, or time 4 seconds, so at 4 seconds, looks like we're at positive 4. Okay, so our final position is positive 4 minus positive 30. That's going to give us negative 26 meters for our displacement to 4 seconds. Right? And then for our displacement to 11 seconds, looks like we're right on the x-axis at 11 seconds. Okay, so that would mean our final position is 0, our initial position is 30, so our displacement would be negative 30 meters. Okay, everybody all right with that? Okay, how many people have done number 3? All right, give you a little bit more time before we go over that one. All right, so we are looking for the total distance traveled, okay, to 2 seconds, to 4 seconds, and to 11 seconds. Okay, that's what the question wants us to find, the same times as the last question. So, easy for the first one, because the distance and the displacement are the same, yeah, because it's going forwards. So it goes from 30 to 50, which is a distance of 20 meters. So all we have to say is 20 meters, this time without the positive, because distance is a scalar quantity. All right, now we have to remember distance is a scalar quantity, so direction doesn't matter. We went 20 meters here, then we went from 50 down to positive 4, okay, which is another 46 meters. So my total distance traveled to 4 seconds is 66 meters. All right, and then to 11 seconds. So now I got to do the rest of this. So I'm going from here, which is positive 4, down to here, which is negative 42. So that's another 46 meters. All right, and then we got to go back up to here, okay, which is going to be another 42 meters, because 11 seconds we were right on the x-axis. All right, so we've got 94 and 134, 136, 156 meters. Okay. Everybody all right with that one? Yeah. Okay. Some people have done number 4. Okay, let's look at number 4. Okay, so number 4 wants the displacement between 2 and 4 seconds. Okay, so that's our first one. So here we are at 2 seconds, here we are at 4 seconds. We've already done that one. It was from 50 to 4 is negative 46 meters. Okay, remember displacement is vector, final position minus initial position, so that is 4 minus 50 for negative 46 meters. All right, between 4 and 8 seconds. All right, so time 4 seconds, our position is positive 4, and at time 8 seconds, looks like we're at 33. Okay, so we're going to have negative 33 minus 4 should give us negative 37 meters. Okay, for our displacement during that part. And then from 12 to 16 seconds. So at 12 seconds, we're right here. That's 20. So that's our initial position. And at time 16 seconds, we're here. 12. So our displacement during that time should be negative 8 meters. Okay. Everybody all right with that? Okay. When people are done number 5. Okay, I'll let you get ahead of me again. Okay. Then for the velocity between 2 and 4 seconds, okay, so we're going from 50 back down to here, so we already know that's 46 meters, negative 46 meters. Okay, so V will equal negative 46 over 2, so that will be negative 23 meters per second. And then between 4 and 7 seconds, so we're going from 4 to, where are we at 7 seconds? Right here at 24. So that would be negative 28. Okay, so V will be negative 28. That's our change in position over 3 seconds. So, that wasn't fun. You can't do that one in my head. It comes up to a decimal. 9 point something, right? 9.33. Okay. And it's negative 9.3 meters per second for that one. And then for D, between 9 and 11 seconds, so at time 9 seconds, that's right here. Okay, so that's going to be at negative 42. And 11 seconds, we're back at 0. Right, so that's going to be positive 42 meters. And it's between 9 and 11 seconds, so that's over 2 seconds. So we're looking at positive 21 meters per second for our velocity there. Okay. All right, remember I said you didn't have to do number 7. So for these ones here, you got some sections to look at, but you've already done a lot of the work for these. So like, don't do it twice. If you already know what the distance was for here and here and here, don't calculate it again, okay? Reuse it so you can save yourself some work on calculating the total distance, average velocity, average speed, and total displacement over the whole trip. All right, give me a few minutes to get ahead of me on that one, and then we'll go through that. And then I think it moves on to the velocity graph, right? Yeah, it does. Okay. Okay, so let's have a look at these ones here, guys. So we're looking for the total displacement over the entire trip, which is a nice quick calculation. Okay, total displacement is final position minus initial position. Our final position is negative 2 meters. And our initial position is positive 30 meters, right, which gives us a total displacement of negative 32 meters. Okay, everybody all right with that? Okay, total distance traveled. All right, well, we already knew that this one was 20. We knew that this one was 46. We knew that this one was 46. We knew that this one was 42 because we'd already calculated all of those. Okay, and then from here to here, I think we'd already calculated that one as well. Okay, that this was 27, right, because it goes from 0 to 27. And then it goes from 27 down to negative 2, which is another 29 meters. Okay, everybody all right with that? What do we have to do with those numbers? Add them all together. All right, so we've got 66 plus 46 plus 42 plus 27 plus 29, right? You get them all? 210? Okay, 210 meters. All right, that's scalar, so we don't have a positive or negative on that. Okay, average velocity and average speed are now both pretty simple calculations. Average velocity is total displacement, that number right there, divided by total time. So negative 32 divided by 18 seconds. Okay, it's going to give us, what, 1 point something, 1.9? Negative 32 divided by 18, negative 1.7, 1.8, let's say, because it rounds up. Negative 1.8 meters per second is the velocity over the whole trip, and then average speed is total distance, which we already have. Okay, 210 meters divided by the total time, okay, which was 18 seconds. So 210 divided by 18 gives us 11.7 meters per second. Okay, questions on any of those? Would I ever give you one that involved on a test? Never. Okay, it would be more like what you saw in the quiz this morning. All right, any other questions on the position time graph? Okay, then moving on to the velocity versus time graph. So the first thing you got to find here, okay, or actually these are all the things you have to find, okay, A through G from that graph there. All right, so I'll give you guys some time, then I'll go through A, and I'll go through B, and I'll go through C, and so on. So let's have a look at least the first couple here. So total displacement over the whole trip, well, that's probably like the longest thing to do. Hold on. Okay. Probably the longest thing to do on this graph because there's a lot of shapes here. Okay. So what I did for this one was I made a triangle right here. Okay. I made a rectangle that went to there, a triangle, and a rectangle, and then this triangle, like that. Those are the shapes I drawed. Okay, you might have drawn different ones. Okay, but in the end, we'll all get the same area regardless of how you drew the shapes. Okay, maybe you drew more than that. Well, then you just made more work for yourself. That's fine. Okay, so what we're looking at here is just getting the areas of all these shapes. So for this rectangle right here is where I'll start. Height of 2, base of 10, so that's 20 meters. Okay, this triangle here has a base of 3 and a height that goes from 3 to 12, right? So a height of 9. So 3 times 9 is 27 over 2 is 13.5. Then I've got this rectangle here that runs from 3 to 10, so it's 7 seconds on the base, and it is also 9 high, so that would be 27 meters. And then this triangle here is 1, 2, 3, 4 on the base, and it goes from 12 to 27, so that's 15 high. So 15 times 4 is 60 over 2 is, that's not right. 1, 2, 3, 4. It is. How can that triangle? Did I mess this one up? This one? It is. I must have messed this one up too. There's no way this triangle can be 30 and this only be 27. I messed something up there too. 7, and it's, what did they say high? 3 to 12. 7 times 9 is not 27. That's why it didn't make any sense, because I can't multiply today. Okay, and why I shouldn't do things in my head, but I'm going to continue to do them in my head because I'm stubborn. All right, 1, 2, 3.5 on the base, and it goes up to 28. Okay, there, 28. Yeah. Okay, so that one I need a calculator for. 3.5 times 28. Divided by 2. All right, we're looking at 49 there. Okay, and then we've got these shapes here. So this one goes down to -12, and it's 1.5. So that'll be 18 over 2 is 9. Is he stubborn? Still stubborn. Okay. Too high by 1, 2, 3, 4, 5. So that one's 10 meters. And this one's 5 on the base. And let me see, 12, 2 is 10. Okay, so 10 high, 25. Yeah. All right, add those all together. You get the total distance traveled. Oh, I forgot the little triangle. Okay, sorry. 2 on the base and 2 high, so it's 2. Okay, so add those all together and you got your total distance traveled. Okay, and then the other thing it wants is the average velocity over the whole trip. All right, I keep all these numbers. Okay, I don't mess with any of these numbers except I make these ones all negative. Then I add them up again. And then I'll get my total displacement and divide it by my total time, which is 23 seconds. Okay. And then, as I'm running out of time here, okay, acceleration between 10 and 15 seconds. All right, so at time 10 seconds, our initial velocity is positive 27, and at 15 seconds, it is negative 12. So we got negative 12 minus 27, and that takes place over 5 seconds. Right, so we got what, negative 39 divided by 5. That'll give us our acceleration in meters per second squared. All right, so tomorrow we're doing a lab, velocity versus time graphs. Okay, that'll be the end of graphing in class. Still be on the test. Okay, and so on Thursday we'll be starting work energy theorem, which is the most important thing ever. I kid you not. Okay.